Good morning, students. Today we discuss about second phases of the compiler is nothing but our syntax analysis. In the syntax analysis phase, for doing the work, what is the work is doing means it will be check the syntax of the given grammar. The syntax verification process will be carried out in two different ways. One is top-down parsing, another one approach for bottom-up parsing. So now we discuss about top-down parsing methodology. So top-down parsing means the parse tree is, so the syntax analysis output is parse tree generation. So parse tree generated. So parse tree is created in the parse tree is created with the help of top to bottom approach that will be implemented. So top-down process approach will be in two different ways. Recursive different parsers, two different parsers are available. One is recursive descent parsing, second one is predictive parsing. So today now we discuss about predictive parsing methodology. So predictive parsing methodology, the syntax will be verified with the help of predictive parsing methodology means we have the given context-free grammar production rule without having left recursion, left factoring, and backtracking. So predictive parsing is very important and very efficient method for verifying the syntax of the given source program with the help of minimum concept or minimum concept of the languages. Minimum concept of language, sometimes it is given a small type of languages. It's not for more complex languages. So small type of languages is very efficient method for top-down approach in predictive parsing. So generally we call it as predictive parser. Another name is LL1 parser. So LL1 means we have identified some lookahead input symbols by using the number one is represented by with the help of some input symbol. The LL means first L represents read the input character from the input string in left to right manner, so that the first L is indicated. Second L indicates that its derivation operation is based on leftmost derivation of the derivation process, so that read the input from left to right manner and also to write the leftmost derivation, so that the grammar is called as LL1 grammar. So recursive predictive parsing is a special form of recursive descent parsing without backtracking is another name. That is our simplest introduction. So recursive descent parser using backtracking means, what is the meaning of backtracking? So backtracking is needed whenever, definitely we require for backtracking for their choosing an alternative solutions. It tries to find the leftmost derivation. For example, S gives A capital B small c, B gives small b c or next B alternative. So derivation will be started from main root node, that means starting symbol of the given grammar. So S is derived to A, B, C. Now next non-terminal capital B is replaced by small b and small c or another one alternative B. So now we consider the input small letter A, B, C means what is the derivation process? First S is derived, which is indicated. S is replaced to A, capital B, small c. Next capital non-terminal B is presented. The B is replaced by either small bc or small b. So first we have to choose B, C. So the input will be read from left to right manner. So A, B, C, C. But our input is A, B, C. So that particular derivation is not possible. So we go for the previous safer side. So B, C replacement will be capital B is not taken. So next alternative small b. So capital B is converted into small b is our solution. So that particular case backtracking. So these type of backtracking process are not required in predictive parsing methodology. So predictive parser. So predictive parser, what we discuss means a grammar eliminate left recursion, left factoring is not required. If it is available, we need to be eliminated. So that is the concept for we are referring for left recursion and left factoring concept we are implemented. So predictive parser, LL1 parser, what are the process we have done? So start with your predictive parsing. First we represent the input buffer. The input buffer is our string is to be parsed. What type of input we need to be parsed? That particular input characters are stored in input buffer. So we will assume that it's end marked with a special symbol as $, which is indicates the end of the input. So we end up the input symbol, we represent it as $ symbol, which is indicates the end of the input characters. Our input, everything will be stored in the input buffer. The input buffer is presented is each and every cell. So input characters, each and every character will be placed in each and every input cells. Output. So given input, what is the output of the LL1 parser? A production rules representing the step of derivation sequence or the string in the input buffer. So from the input buffer, the LL1 of parser will be read the input from the input buffer and parse the input in the help of the parsing table, and finally it produces the output as whether the input string is accepted. That means derived or not. If it is derived, the input is accepted, otherwise input is rejected. Here we are using stack data structure. Stack data structure means contains grammar symbols. So only it will be stored for non-terminals. At bottom of the stack, there is a special end marking symbol is $, which is indicates the top of the stack or empty stack. Initially, the stack contains only the symbol $, and end with and add the starting symbol yes. So initially stack contains $ symbol is the very bottom of the stack, and the top of the stack will be capital letter S. S is nothing but starting symbol of the given grammar. Parsing table, next one. So parsing table which contains row and column values. Row values are represented in terms of non-terminals. Column values are represented in terms of terminal characters and epsilon and $ symbol which is used in the given grammar. So the table representations will be accessed in two-dimensional array concept. So what is the two-dimensional array means? Row and column value at a time we have to choose. So two-dimensional array. So M of A comma A. Here M is the matrix value, capital A is the non-terminal, small letter A is a terminal character. Each row is the non-terminal symbol, each column is the terminal symbol, and as well as the special symbol $ will be also added. Each and every entry holds some protection rules. Suppose the entry which was not having any other value, this should be the empty means it is represented as error. So this is our LL1 parser. Brief introduction. What are the concepts? What are the elements? What are the points are needed or understand for LL1 process? So input buffer, output, stack, and predictive parsing table. These are the main content are involved in the LL1 parser. So LL1 parsing accents in terms of table. So if X and A are represented as $ symbol means if the symbol at the top of the stack we say that X, and current input reader symbol we say that A. So top of the stack will be here in general concept we called as top of the stack is X and current reader input is small letter A. So if X and A both are all in $ symbol means this indicates that alt level, successful completion. If X and A are the same terminal symbol, different from $, same terminal symbol, parse the pop X from the stack and move the next input symbol in the input buffer. Next, we need to pop the X symbol, pop operation will be implemented in the stack operation. So from the top of the stack, X will be removed, top of the element will be removed, and simultaneously in reader input A is kept out and move to the reading operation of next input character. If X is non-terminal, parse the lookup operation M of X comma A, it's nothing but it's F of X comma A, hold the production rule, X gives Y1 or Y2 or up to Y, n number of rules will be presented means. For example, S gives XL, generally represents more than one X non-terminals are available means. Just we need to remove the top of the stack. For example, X is in the top of the stack, so it will be removed from the stack, and Y1, Y2, Y2, Y3, Y4, Y up to Yk, the symbols, everything will be inserted into the stack in the reverse order. So automatically Yk is first, Yk minus 1, Yk minus 2, Yk minus 3 up to Y2, Y1. So now current top of the stack will be Y1. This is the way in terms of non-terminal reader it will be implemented, or parsing access will be carried out. If none of the above means all the above cases, 3 cases are available, is out of above 3 cases not matched means it will be represented as error. That's why previously I told that in the symbol table entry, empty cells will be represented as error message. So just we go for, before going to LL1 parser input parsing, the table entry will have to represent. So LL of 1 parser, this is the way, this is our table entry representation, the corresponding production to table entry. How this table entry will be made? That will be called as first of non-terminal will be calculation, follow up the non-terminal of each and every non-terminal will be calculated. So now we called for first of E value, first of E dash value, first of T, first of T dash, first of F. The first of F means we start with the non-terminals in the sequential order in the given grammar appearance. So first E, next E dash, T, T dash, and F. If E equal to E means, what is the first of E? Equivalent right hand side, what is the first character? Capital T. So that particular capital T is terminal character, means we can add it. Otherwise, we need to again to identify the first of T. Now we compare with first of T, equivalent right hand side value will be F. First of F we need to be find. First of F is equal to open bracket and ID is the second alternative. So first of F equal to open bracket ID. The same thing will be for first of T. So first of E equal to open bracket ID. That will be again stored into first of T. So first of T equal to open bracket ID. That T value will be assigned to E value. So first of E equal to open bracket ID. F T E. Next E dash. First of E dash having two alternatives. So both the alternative, the first character will be plus and epsilon. Both are all terminal. So plus comma epsilon. First of T already find. First of T dash will be two alternative. First alternative will be star. Second alternative will be epsilon. So first of T dash is equal to star comma epsilon. So now the first of E value, first of E, T, F, E dash, F, F, T dash, everything will be called. Next, we called for follow of E. So follow of E, how it will be calculated in terms of 3 production conditions are there, and along with one special value. One special value is nothing but whatever the given problem, whatever the given condition, what is the first, identify the what is the first starting symbol of the given grammar. For example, in this particular grammar, now E is the starting symbol. So follow of E means you can add the dollar symbol as a default value because E is the first starting symbol. Follow of the starting symbol is nothing equal to, by default dollar will be added. That is the very first point. After that, the follow of T will be calculated in 3 different ways. First, we need to be identify where the non-terminal is present in the arrow mark right hand side. The corresponding position to be identified first. So follow of E means in the given problem, simplified problem, arrow mark right hand side, how many places E will be present? Here only one location. Similarly, E dash 2 locations. T 2 locations, T dash 2 locations, F 2 locations. So whatever the how many times the corresponding non-terminal is presented in the arrow mark right hand side, we consider all the cases. First we call upon follow of E. Follow of E means E available in only one position. What is the immediate right hand side of the value? Is nothing but close bracket, which is nothing but the terminal character. So we can add the follow of E is equal to close bracket. Here dollar will be present. So follow of E is nothing but dollar comma close bracket. Now, next will be follow of E dash. Follow of E dash means two locations are there. You can identify both the cases. E dash right hand side is none of the character will be available. So that particular situation we called the corresponding production rule left hand side non-terminal follow. So E dash arrow mark left hand side will be capital letter E available. So what is the follow of E? Dollar close bracket. That will be taken out. Suppose again one more time I will repeat. Follow of E dash. E dash will be present in the arrow mark right hand side in tool space. Both the spaces immediate right hand side of the dollar E dash will be nothing available. That means epsilon not available. There is no terminal. There is no non-terminal. There is no element. That particular case, the corresponding production rule left hand side non-terminal. What is the value? The corresponding non-terminal follow will be taken as and write it here. So automatically follow of E dash is equal to follow of E. Follow of E already we called as dollar comma close. Next follow of T. Follow of T having two different locations. Both the locations are immediate right hand side value will be E dash, which is also one more non-terminal. That particular case we called as follow of T, we called for E dash. So non-terminal. So again we combine together first of E dash union follow of U dash minus epsilon. Here minus means set difference. So that particular case, first of E dash already we calculated plus comma epsilon. Follow of E dash already we having dollar close bracket. So follow of E dash is nothing but plus epsilon symbol dollar close bracket. With the help of minus epsilon, that means set difference, we eliminate the epsilon character. Finally, we will get plus close dollar symbol. Similarly, for follow of T dash will be calculated plus close dollar. Follow of F will be plus star close dollar symbol. So in this way, follow will be calculated. Next step, we go for parsing table. So that particular parsing table will be calculated with the help of two-dimensional array format. So here 5 non-terminals are using, so 5 row will be added. How many terminal characters are here using? Identifier, plus symbol, dollar symbol, open bracket, close bracket will be added. So plus identifier plus star open bracket close bracket dollar will be here presented. Now first of what we calculated open bracket ID. So we can entry for ID entry and open bracket entry. So what is the production rule available in terms of E? E gives T E dash. So E gives T E dash will be added in the ID entry and open bracket entry. Next E dash is first value will be plus epsilon symbol. So at the time of E dash plus entry, E dash epsilon entry we consider last. So E dash plus entry we called as E dash gives plus T E dash. But E dash gives epsilon will be considered at last. With the help of follow symbol we can finalize. Next first of T value open bracket ID. So first of T having the production rule for T gives FT dash. So T gives FT dash in ID entry, T gives FT dash in open bracket entry. And next T dash gives star comma epsilon is our first symbol. So here epsilon will be considered the last. So T dash star we called as T dash star will represent as T dash gives star F T dash. And next F having a two alternative open bracket ID. F ID will be we can specific rule F gives ID. In terms of open bracket, F gives open bracket E close bracket having the specific rule. So compare with the same. First of E having open bracket ID. First of F also having open bracket ID. In first of E, both the entry having the same production rule because E production rule which have only one alternative. So that both the cases we can entry for same production rule. But in F production rule having two alternative, the corresponding entry, the corresponding rule will be added. So in terms of ID, F gives ID will be added. In terms of open bracket, F gives open bracket E close bracket is added. Next, first entry will be completed. Next, we will focusing on follow value. Next, first of E dash having the epsilon. So the corresponding entry we need to be checked. The corresponding E dash follow what is the value. So follow of E dash is nothing but close bracket and dollar. So in the E dash entry, we use the corresponding cell of close bracket and dollar. So E dash close bracket we represent as E dash gives epsilon. E dash dollar symbol we represent as E dash gives epsilon. Because first of E dash contain epsilon, so E dash value which contains the first value epsilon, so that we call for follow of E dash. Follow of E dash nothing but close bracket and dollar. So E dash close bracket entry, dollar entry we made up of E dash gives epsilon. Similarly, T dash contains first of T dash contains epsilon. The corresponding T dash follow is nothing but T dash follow is nothing but plus close bracket dollar. The corresponding entry will be made it of T dash gives epsilon for all the three cases. This is the way the table will be represented. And next, the E non-terminal in terms of plus entry, star entry, dollar entry, and close bracket entries are empty spaces without filling any other production rules. That case, we called as these entries are represented as error message. So these are the way the predictive parsing table will be constructed. So LL of one parsing table will construction in the 4 steps. First step, given input string will be identified in terms of context free grammar without having left recursion, left factoring, or backtracking. If it is available, we need to be eliminated. After that, to identify the first and follow of the each and every non-terminal in the given grammar. Next, follow of the non-terminal. So this is second step. Third step, to perform the input operation. Perform the in parsing table construction after that input parsing. Input parsing, how it will be defined? Corresponding entry, stack initially present, stack initially dollar and E is presented. What is the input character? We consider ID plus ID. Now initially stack contains dollar, starting symbol will be inserted into the stack. EID plus ID. So what is the value of EID? In terms of EID means E value is gives TE dash. So that particular case, E value will be removed from the stack and TE dash will be inserted into the stack in reverse order. Upon what is the value? E dash T will be presented. Now TID. TID means the simple the parsing table entry T gives FT dash. So T is removed from the stack. FT dash is inserted into the stack in reverse order. T dash here. Now F gives ID. Automatically F will be replaced by ID. ID will be cancelled. Next T dash plus ID dollar. Now T dash plus the table entry will be T dash gives epsilon. So T dash will be epsilon means E dash will be remaining. So now top of the stack will be E dash plus ID dollar. Now E dash plus the table entry for plus T E dash. Now E dash will be removed from the stack. Plus T E dash will be inserted into the stack in reverse order. E dash T plus. Now plus plus will be cancelled. Next top of the stack will be T ID dollar. T ID means in the symbol table entry T in parsing table entry T gives FT dash. T will be replaced by T dash F. F ID will be the F will be the top of the stack. ID is reader. F ID F gives ID. F ID will be ID changed. ID will be cancelled. Next T dash dollar table entry T dash will be epsilon. E dash dollar E dash will be epsilon. So finally top of the stack will be dollar. End of the input characters also will be dollar. Finally dollar it will be updated. So in this way only the input are passing. So this is the way for representing or constructing the LL of one parsing table and produce the output. That's all about your LL of one parser or predictive parsing table construction. Thank you.